Okay, let's recap what we learned in the first part. We learned that there are atoms. These atoms are made of protons, made out of neutrons, and made out of electrons. We said the protons, they have positive charge and they have a mass. Neutrons, they don't have any charge, but they have a mass. And the electrons, they don't have a mass, but they are negatively charged, meaning that they have negative charge. And also, we said usually in many of the cases, or in most of the cases, number of electrons would equal the number of protons. This is the summary of what we talked about in the first part. And I need you to understand that there are atomic symbols. These are one or two letters regarding these atoms. And usually, in many cases, these are coming from Latin names. Na is referring to sodium, but it is coming from its Latin name. Oxygen, it is oxygen. So, lucky enough, we are going to use uh, just O for it. Okay. Now, two or more of these atoms can come and form molecules. So, molecules is a stable association between two or more atoms. Could be the same atom or could be a different atom. Same atom, for example, hydrogen. Hydrogen is always binding to another hydrogen. So these are like two hydrogens. This is the hydrogen molecule. Okay? Water is an association between two hydrogens and one oxygen. So this is a molecule. Table salt, it is sodium and chloride. Two different atoms came together and they formed a molecule. Now, we mentioned the electrons and we mentioned that they have this potential energy, and we mentioned that they are around the nucleus. They are spinning in different levels of energy, okay? And we said that the more or the farthest or yeah the farthest the electron from the nucleus, it means it has more potential energy. Now, atoms are most stable when their outermost shell is full. What do we mean by full? For our course, we will say that full meaning that they have in their outermost shell 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So once an atom has 8 electrons in its outermost shell, then it is a stable. What do we mean by stable? It means it won't get into chemical reaction. That is a stable atom. But in nature, only few atoms they are stable. Most of the atoms in nature they don't have 8 electrons in their outermost shell. Okay, so most of these atoms in nature they are active atoms. They are going into reactions, chemical reactions, and they are forming chemical bonds. They are forming chemical bonds. And these chemical bonds, attractive forces holding atoms together. These are attractive forces holding atoms together. Now, why do atoms get into these chemical reactions or chemical bonds? In order to get stable, to fill their outermost shell. Think of this atom when it has 8 electrons in its outermost shell, then it will be a heavy atom. But if there is another atom that its outermost shell has, let's say, just 2, this will be devastated, very sad atom. So it will try to do whatever it can, either like to get other electrons or to get rid of these electrons, to get 8 electrons in outermost shell, whether this outermost shell is the third one or the second one. Okay? Now, and that is what we are going to understand. These chemical bonds. Okay? What are they and how they are going to be formed. So, for the chemical bonds, we are going to see 3 different kinds of chemical bonds. We are going to see the ionic bonds, the covalent bonds, and the hydrogen bonds. So these are the three types of chemical bonds we are going to understand. Now, let's start with the ionic bond. In ionic bond, what is happening that the atoms will turn into ions. Okay? These ions can be either positive ions or negative ions, depending on whether they lost or gained electrons. Okay? Now, to understand this, we need to remember that the number of protons equal the number of electrons, right? So if we have 4 here, we should have 4 here, and the net charge is 0, right? But what will happen if we have, instead of 4, 5 electrons? 5, remember, these are negative, these are positive. So the net charge in this case, it will be -1, right? Okay, what if instead of 4, we have 3 electrons? In this case, we have 4 protons, but the 3 electrons. The net charge would be +1. So this is an atom that is gained electron. It means it's gained an extra negative charge. This is an atom lost its electron, or one of its electrons. So it will have more protons in this case, and then the charge would be +1. Now, usually atoms always are going to gain or always going to lose. There is very few examples of atoms that can either lose or gain, and we are not going to see them. For our course, atoms are always going either to gain or either to lose. So when they are losing or gaining, they are turning into ions. Either negative, or since it's green, positive ions, or it is negative ions. And these, as we said, these are going to be different ones. In our course, they are different ones. Now, by logic, if you have a negatively charged atom and positively charged atom, what will happen between them? right? They will get attracted to each other. Oops, no, not this one, not this color. They will get attracted to each other because positive will get attracted to negative, and that is the ionic bond. So the ionic bond is the attraction between negatively charged ion. I'll repeat. The ionic bond is the attraction between negatively charged atom, and positively charged atom. Okay, this attraction is the ionic bond. But from where we got these negatively charged or positively charged atoms? Because one of them gained, the other one lost its electron. Okay, now let's see the example we have in front of us. We have here the sodium, and sodium has 11 protons and 11 electrons. Okay, so the sodium, if you notice in its outermost shell, it has only one electron, right? So the sodium, since its outermost shell is not full, doesn't have 8, sodium is not happy. Let's see chloride. Chloride in its outermost shell, it has 2, 4, 6, and 7. For chloride or for sodium in outermost shell to be happy, both of them to be happy, they should have 8 electrons. Now chloride also is not happy. Now this sodium, in order to be happy, as we said, it needs these 8 electrons to be in their outermost shell. So it's going to give up on this electron. It's going to give it. Let's get rid of it. And if it gets rid of it, it will turn into a happy atom with 8 electrons in its outermost shell. But it is now positively charged. Why positively charged? Because it has originally 11 protons, but now it has 10 electrons. So the net charge now is 1 positive because we still have 1 proton positive. Atoms, they don't lose or gain protons. Protons is kind of their ID. They can't lose it, they can't gain it. But for electrons, it's easy. Okay, now what about chloride? Chloride, it has 17 protons, 17 electrons, and the net charge is 0. But in this case, chloride now, it has 17 protons and 18 electrons. The extra electron came from the sodium. These are 17 plus 1. This came from sodium. Remember, the sodium gave this electron to chloride. So here we have a net charge of -1. Right? So here -1, here +1. And we ended up with the chloride, but it is displaying a negative charge. So a positive atom, negative atom sitting beside each other, they will get attracted to each other and they will form the NaCl, the table salt. And that is the ionic bond. Okay, I will pause again here. Please go over this. See your questions, try to answer them, post them into the forum, and see if you can answer any of your classmate questions. See you in a bit.